Example number 1, I'll read it out loud. It says, find the critical numbers of f, and then we're going to apply the first derivative test to identify all relative extrema of f. And the first sentence really tells us something very clear to do. It says, find the critical numbers of f. So we've talked about this a lot. I think it's worth talking about again. How do we find critical numbers? It's places where
the slope is 0.
okay, let's be really careful. The slope is a little vague. F prime, right? So where f prime is 0 or doesn't exist. Okay, so we want to consider both of those possibilities. In both cases, don't we have to find f prime?
Yes.
So go ahead and do that. Go ahead and find f prime. I'll just write it up here quietly. Give you a chance to practice this on your own real quick. So f prime equals, I'm going to check your answer there. You guys agree with that? F prime equals 3x squared minus 12x. Where'd the 15 go?
It's constant.
So its derivative is 0. Yeah, good. All right, so did you guys consider, is there any input for x that would cause f prime to not exist? Yeah, there's no fractions, right? So there's no possibility of dividing by 0. So I think we're okay on that front. I think we can safely move past that. But I think this is going to give us some answers, right? Equals 0. Please remember, again, I find myself repeating myself a lot. That's for a good reason, right? Equals 0, doesn't that have value associated with it? And so setting something equal to 0 will almost always be associated with a point or part of a point on any particular quiz or test. So please write it down. Don't just think it, write it. All right, so we got to solve this now, right? Give you a chance to solve it. So take just a minute. Maybe you've already done that. I'm looking around. It seems like maybe some of you have. What strategy did you guys use? What did you use?
Factor out the x.
Okay. What's left over?
3x minus 12.
Sure. Yeah, this works just fine. And then don't we do the pre-calc thing where we set each factor equal to 0? The zero product property. Yeah. So x equals 0. And did you guys also get x equals 4?
Yes.
Okay. So I think it's always important for us to stop whenever we kind of reach an important spot here. It's important for us to stop and ask ourselves, what have we done? So what have we done?
Found the critical number.
We found the critical numbers. We found the candidates, right? So it would be wrong to stop here. All we found are the candidates. We need to identify, are they relative mins, maxes? Is it a mix? Are they neither? We have to actually identify that. And the way that we identify that is with the first derivative test. We're going to literally test the first derivative. To do that, we're going to make a sign chart. I think a sign chart is a good graphic for us. So, little number line. I always label my sign charts for what they are. This is going to be an F prime sign chart. Later on, we might do an F double prime sign chart, and that would mean something entirely different. So I usually label these with, whatever they happen to be. We always put our critical numbers on the sign chart, so 0 and 4. In doing so, I've created some intervals, right? How many intervals have I made?
3.
3 of them, that's right. So we have to basically test out these intervals, and we're going to test whether f prime is either positive or negative within these intervals, and from there we can make a conclusion. So how do we test the intervals out?
Choose a number.
Some number, yeah. Number to test out. So what do you suggest? 2? Yeah, 2 would work. 1 would work. You want 1? Okay, so let's do 1. So I'm going to write f prime of 1 equals, and what does f prime 1 equal? It's so much easier, right? Yeah, negative 9. Yeah, totally right. Negative 9. And so what I can do then is I can just put a negative sign on that whole interval there. And I do want to check in with you guys. Like, why is it that I can test one number in the interval? Like, all I did was test one number out. How could I then say the entire interval is now negative? How can I do that?
Because the points that we found are the points where the sign changes, and we know that those are the only points where
We don't know the sign changes there.
where the sign could change.
Because that's where f prime is.
0.
Yeah.
But it doesn't cross 0 any other place, like in between those.
There's no possibility other than these unless the function is not continuous. We kind of glossed over that, but you do see this as a polynomial, right? And a polynomial is always continuous and differentiable, so I think it's safe to just kind of blast right on through that. But that's why we can actually do this. We can assign a sign to an interval based on just a single test value and do that with confidence. So, if you guys remember, we did talk a little bit about multiplicity last time. And if you know multiplicity, use it. If you don't, don't. If you want to know about it, come see me sometime outside of class. Be happy to talk to you about it. But if you are not comfortable with multiplicity, then you got to do 2 other test values, right? So what do you guys suggest for the left interval? Yep, so f prime of -1 definitely makes sense. Did you already do that, Madison?
Yeah.
What'd you get?
15.
15, yep, I agree with you there. Multiplicity would have confirmed that. Multiplicity would have said there will be a sign change at 0. And we see that with for test value. It makes sense. And then what about the test value for the right interval? You guys use 5?
Yeah.
5 makes sense. So f prime of 5,
Also,
and it is, yes, 75 minus 60, right? So 15. The important thing about that, of course, just like the other numbers, is that is a positive number. So, this right here, guys, is not enough. We need to tie this together with a conclusion, a sentence or two, a conclusion with some kind of a justification explaining why you picked what you picked. So, but just looking at the sign chart, here, what would you say x equals 0 would give us for f? Would it be a min or a max or neither? Yeah, f prime is going, we always judge this from left to right. So from left to right, we go positive f prime to negative f prime, so 0 should be a max. And then don't we get the exact opposite pattern for x equals 4? F prime goes from negative to positive, so x equals 4 would give f a relative minimum. So can I write one of these up here for you? Let me just give you an example of what you could do. I will do it in a different color. Let's go with this one. Here we go. So I'm going to say f. Notice I'm naming something, right? I'm not saying it or they or them or whatever. I'm saying f has a relative max at x equals 0 because f prime changes from positive, you can abbreviate if you want, like, pos, P-O-S, to negative, N-E-G, at x equals 0. So that would be a way to conclude things, right? So that's a conclusion tied in with a justification. Question?
Would you say x equals 0?
Great question. Usually we're interested in just the x value location. It's possible, and I'll try to, I would say this would be your default. It's definitely possible. A question might say, what are the relative extrema parentheses x comma y? In that case, they're wanting both coordinates for whatever reason. Yeah, but typically these are asking for, like at least in this format, probably where it's happening as opposed to what it is.
Okay.
Good question. Anybody else with a question? Okay. And of course, based on this question, you could find that relatively easily, right? You could take 0 and plug it back into f and get 0, 15, right? And that would be the actual location of this. But I'm just interested in the x value right now. Yeah. Okay, so if there's no other questions, let's see if you guys can write something similar. I would encourage you to write this in your own writing. So instead of like looking back at what I wrote, just try to think about how would I formulate this in my own brain. Start trying to get your own wording down, internalize it a little bit. See if you can do that for x equals 4. All right, ready to go. What you wrote?
Sure. F has a relative minimum at x equals 4 because f prime goes from negative to positive at x equals 4.
Okay, it goes from positive. You say positive to negative or negative to positive?
Negative to positive.
Okay, so negative to positive at x equals 4. Okay. What do you guys think? Do you get it okay? You agree with her? I mean, it's really similar to what I wrote up there to begin with, but it's okay. It's right. I just encourage you guys, as you work on these, and the notes aren't maybe like right in your face, as you work on your own formulation, like how you would do these. Are there any questions at all? Okay, let me show you one other way to think about this. Is that okay? Wouldn't it be true to say that at x equals 0, f prime is not changing at all? At x equals 0, f prime is just 0, right? And so I actually went back and looked in your book to confirm this. Your book actually uses this exact wording. So I kind of feel like if you use this wording, I don't think anybody can really argue with you. But if you wanted to be really nitpicky, you could be pretty nitpicky. You really could. You say, well, hey, when x equals 0, f prime is just 0. It's not changing at all, right? Make sense? Being kind of nitpicky there. I want to show you just one other way to think about this. You could do this. You say something like f prime is positive on the interval, negative infinity to 0. You see that from your sign chart? F prime is positive on the interval from negative infinity to 0, and f prime is negative on the interval 0 to 4. So I'm actually spelling this out a little bit clearly. I'm saying all the numbers to the left of my critical number, f prime is positive, and all the numbers immediately to the right are negative for f prime, right? So I could say, therefore, f has a relative max at x equals 0. This is a finer point right here. I know I show this every year, and I feel like some folks kind of latch onto this and are like, this is how I want to do it. So I show this to you. If you write what you have there in blue, I'm going to give you credit for it. And I've looked, like I said, I actually looked at multiple books just to see, okay, do they all really say this? And they all really say, the stuff in blue. So I don't think that the AP folks are going to be like, ooh, I don't think that's right, when every single book says that, right? So I think you'd be safe with the blue one, but I think the green one there has its value as well. And you could do the similar idea for 4. So anyway, I thought I'd show that to you. Not something that you have to do, but just a different look at it. So, all right, let's move on to example question. Sorry, yes.
So if it asks for if it asks to find the numbers where it is increasing and decreasing.
Yep.
Is that when you would use the f prime of 1, f prime of 5? And
Yeah, that's kind of like what we did last time, right?
Yeah.
So
is that when you would use the numbers that you just on the intervals that you picked?
yeah, definitely. And I kind of did that here, though. If you look at it, I did show, you're talking about how you use the test values.
Yeah.
So this question could have been worded a little differently. It could have said, find the critical numbers maybe. Maybe it would have said that still. But then it would have said, find the intervals where f is increasing.
Yeah.
Right? So if it said, find the intervals where f is increasing, we would say f is increasing. You tell me on which intervals.
F of -1.
So if I say intervals, I'm looking for
So negative infinity to 0.
and
then 4 to infinity.
yeah, because f prime
Is positive.
on those intervals. Yep. So you could have asked a whole different question here.
Okay.
And it's certainly related. We do some of the same things, but this one is asking for a conclusion regarding relative extrema. The other one is just like, hey, where is f increasing or decreasing?
Okay.
That makes sense? And previous one, it does say find the critical numbers of f. So I want you guys to take a minute and do that. Find the critical numbers of f. And then we'll work on the first derivative test and all the sign changes and what may or may not happen. 0. Okay, so let's kind of loop all the way back around and see if that makes sense. Do you guys all find f prime? So did you get f prime equals 2/3 x to the negative 1/3? Okay, so do we all agree on that for f prime? Okay, so Mandy, why do you say x equals 0 is a critical number?
So we tested it 2 ways. I set it equal to 0 first, and I solved for x and x equals 0, and then I changed forms of the equation, and I did 2/3 over the cube root of x, and at 0.
So like
it's
this?
undefined. Yeah. At 0, f prime's undefined. So.
Okay, so she said she tested it 2 ways. You said both times you came up with 0. What do you guys think of that?
That's all I could get.
You're greeted with silence. Welcome to my world, Mandy. What do you guys think?
Wait, can you say that again? That explanation?
So we haven't made a judgment whether this is right or not. All I'm saying is, here's what she said. She said we have a critical number at x equals 0. So, oops, let's try that again. She's saying, our only candidate here is x equals 0 because, she found the critical numbers, and she said she found that same critical number 2 different ways. She said she found it by setting f prime equal to 0. That would be the one on top. And then she said she also recognized that, if you actually did flip that x to the negative 1/3 down where it goes, that a 0 would cause that to be undefined or to not exist. Am I restating it well? Okay. So does that make sense now, John, what she said? Okay. So where do we stand? Like, we were greeted with a few head nods and mostly silence. A thumbs up now. I love it. 2 thumbs up. Yes. Cool. 2, double thumbs up and everything. Sideways thumb. Sideways thumb. No other reactions? So, finger guns. Ooh, yes. And snaps too. This is getting inspiring. I feel inspired now. I feel inspired to say she's half right.
Wait, is it because,
Is it because?
the one on top, it still does not exist, like it doesn't equal.
Let's hear what Caroline has to say.
Why are you just saying 2 of them? Like, shouldn't you bring the X down?
I didn't do any of this. She's the one that did this.
Okay. Maybe. It's like, you bring the X, like, negative down, under, and then test both of them. So.
Okay, so you're saying go ahead and flip down right away?
Yeah.
Okay. Is that what you're going to say too, Delaney?
Yeah.
Yeah, okay. I like that idea. I think flipping down is a helpful thing. Can we focus on that top equation first? And I'd like to take your guys' advice and do that. So I'm gonna actually erase this. This is actually really good work. We'll come back around to it here in a second. This top one is where we have the issue. Let me explain why. If we take this, we say, okay, 2/3 x to the negative 1/3 equals 0. It's really important for us to recognize that x to the negative 1/3 is really a denominator, isn't it?
Yes.
Okay, so if we did that, if we took their advice and we said, okay, it's 2/3 times, x to the 1/3, or of course you could say cube root of x is really what x to the 1/3 is, right? Equals 0. So there's a number of ways to approach this. One of them is philosophical. One of them would be say, okay, I've got a fraction. The numerator of that fraction is 2, and that's never going to change, right? The numerator is just a 2. The denominator involves what? A variable. That's important, right? So what part of a fraction, the numerator or the denominator, has the power to make the whole fraction 0? Only the numerator, and the numerator would have to be, in order for that to happen, the numerator would have to be 0. The numerator is 2, and there's nothing we can do about that. So I would look at this equation right here and say, just philosophically, this is never going to work. It never works. We could look at this procedurally. Think about this. If we're going to do this like in a procedure, like with some algebra steps, we want to get that x out of the denominator, don't we? How do you get the x out of the denominator? Multiply by it, right? Yeah. So if I multiply both sides by the cubed root of x over 1 technically, right? When I multiply here, wouldn't this cancel with this?
Yeah.
And when I multiply here, what's anything times 0? So I'd get 2/3 equals 0. Last time I checked, that's not true, right? And so this, based on both of these steps here, you'd have to say there is no way for f prime to equal 0. There's no way. F prime simply never equals 0. It never touches or crosses the x-axis, ever. But your other way of thinking is right on the money. So if we go back to this and we say, well, that x to the negative 1/3 is really a denominator, then we could say, 2/3 times the cubed root of x equals, we don't know. Well, 0 didn't work. What's the other way to get a critical number? Undefined, yeah. So equals dne. Well, is there any number we could plug in for x that would cause this f prime to not exist? 0, right? Because the cubed root of 0 is 0, times 3 is 0, causing a 0 in the denominator, causing f prime to not exist. Therefore, our critical number, our only candidate here, is x equals 0. So do you see how she got a good answer from some somewhat faulty thinking? It was half right, half wrong. I just want to make sure that that's as clear as possible. So you led us to a good place, and honestly, if this were multiple choice, we'd never know the difference, would we? Because you said x equals 0. So, yeah. So are we in a good place now? Does all that make sense? Caroline, go ahead. I said f prime could never equal 0. F prime will never equal 0. However, if x is 0, f prime doesn't exist. This is where it's, Caroline, I totally get it, and I thank you for asking the question. This is where we've fallen into that trap in the past of just thinking, at least thinking in our heads, it is 0, it is undefined, it exists. versus saying a name. F exists. F prime doesn't exist. X equals 0 versus it equals 0, right? It's easy to fall into that trap. I would encourage you to try to name names. Okay? All right, so x equals 0 is our lone critical number. What do we use? This is our only candidate. What do we use to test whether that's a min, a max, or a neither?
Numbers.
Numbers, also known as the first derivative test. So make a little sign chart, use the first derivative test, and see if you guys can finish it now. Come up with your own conclusion, your own words to determine whether x equals 0 is a min, a max, or neither for f. From the first derivative test perspective, I'm going to make a little sign chart with a little number line here. I'm going to put the 0 on here, and this is an f prime sign chart. So for my values, what did you guys use for test values here? Negative 1 and 1 make a lot of sense. So f prime of negative 1, so we're testing this back in the f prime equation. You should end up with negative 2/3. If you use your calculator, of course, it'd be negative 0.66666, right? So equals negative 2/3, and so I would just put a negative sign right there. And then if you tested out the 1, which I, again, think is an intelligent thing to do, you'd end up with positive 2/3. Of course, the important part there is positive. And so based on that, you can make a judgment. Maddie W., what kind of a conclusion justifying statement did you have?
I said f has a relative minimum at x equals 0 because it goes from negative to positive at x equals 0.
I'm just catching up to you. Okay, did I write that down correctly, Maddie? F has a relative min at x equals 0 because it goes from negative to positive at x equals 0.
Yeah.
Okay, what do you guys think? Reactions? Good?
Well, what's in?
I got to ask that question.
F prime.
F prime, yes.
What is it?
So this right here, this is the word that's going to cause some struggle, right? If you use, I hate to bring this other class into our sacred room, our sacred space here, but if you look at the English grammar of it, there's such a thing as pronoun antecedent agreement. The antecedent for it is actually F, and that makes this wrong. See what I'm saying? The word it is actually referring to F, which would make this an incorrect statement. And so instead of writing it, as you all suggested, write F prime. Because F prime goes from positive to negative. And I would encourage you, think about this. Physically speaking, like your hand actually writing on the paper, it is no more difficult to write F prime than it is to write it. You could even argue that it's a little easier. But be careful though, because what if it starts to change meanings? It could. So I would, now you're creating more of a tangled mess than we had to begin with. That's why earlier I did this. It is banned, right? Okay, Maddie, does that make sense? You obviously did a very good job. You just misused the word it. The way I would think of that is I'd say Maddie misspelled F prime, right? She just misspelled F prime. Okay, take a look at example 3. I would say that examples 1 and 2 are somewhat algebra heavy, somewhat. And I would say that examples 3 and 4 coming up are a little more conceptual. And I like both. I would think that you'd want to be ready for both. But I like the conceptual ones because I can assess you pretty quickly and easily in a short amount of time. So please read with me example number 3. It says a differentiable function. Differentiability implies what? Yep, so a differentiable and continuous function f has one critical number at x equals 5. That fact right there you'll find later is pretty important. Identify the relative extrema of f at that critical number if f prime of 4 equals negative 2.5 and f prime of 6 is equal to 3. Justify your answer. So there is no arithmetic to be done here. Very little what people would think of as math. There's a little bit of writing. Okay, so write 1 or 2 sentences here to figure out what's going on and justify yourself. Okay, so take a few minutes and do that. got to kind of close this one up. So, just like for a quick answer, it's really asking, relative extremists. We're talking about relative min, max, or neither. What do you think we have? Just shout out, what do you think the answer is? Relative min. I agree with you. So just saying that is not going to be enough because it says justify your answer. It's going to have to be a little bit of a sentence. So we could start it off like this. We could say something along the lines of F has a relative min at x equals 5 because, go ahead, Pristine.
Because F goes from negative to positive at x equals 5.
Because,
F prime.
there we go, F prime goes from positive to negative. Okay, guys, don't pack up yet, please. At x equals 5. So, Pristine, that's well said and correct. Of course, the fact that there's only one critical number makes all the difference, right? Because, if there was more than one critical number potentially, then this reasoning could be completely wrong, couldn't it? Can I read this to you using improper language? Think about how confusing this is. Just listen to me. This is what I would not want you to say. It has a relative min at x equals 5 because it goes from positive to negative at x equals 5. Didn't I just use the word it to refer to two totally different things? So that's why I want to just completely avoid the use of the word it. Name it, right? Name it, it's F prime, whatever it is. Call it by name. See you guys later. Have a good day.